Math 2 students, this is lesson 912, which I didn't really call it that, but this is the Parabola Investigation, which is from lesson 912. So if you did not finish it during class when we were together, or you haven't done it on your own, this video is there to help you. Now, just a disclaimer, try it first. Use this video if you are stuck. It is more fun and it will stick with you longer if you come up with it on your own. So the first thing we're going to do is try to make it stretch vertically. And so if we recall, there were some hints given to us in the instructions that said try multiplying, try adding, try subtracting, try negative numbers and decimals and fractions, and then you're going to record what works and what does not. So the first thing I'm going to do is get x squared in here. There it is. So I've retyped it. Now I'm going to put something in front. So either I'm going to times or add. Let's try subtracting. Okay, that didn't work. It's not stretch vertical, which means it would have the same vertex. Okay, it says same vertex, and it would get skinnier. And so this did not get skinnier. It has moved down. So on my notes, I'm going to write x squared minus 3 does not work. It moved down instead. Let's try adding. Okay, that moved up. Let's multiply. 7. Oh, that got skinnier. It worked. Let's see if multiplying by something else works. So that worked. 7 makes it skinnier. 3 makes it skinnier. 6 made it skinnier. 2 makes it skinnier. 1.8 made it skinnier. Not skinnier. 1.8 worked. The rest didn't. Basically, you multiply by a number larger than 1. So 1 won't, but any number larger than 1 will make it skinnier. It's stretching it, which means it's getting larger faster, which is why, because you're squaring it and then timesing by 5 after, so it gets large fast. Okay, let's try the next one, which is to compress it vertically, which means to make it wider or fatter. Now, if you notice, I did that accidentally when I was playing with the decimals. So I'm going to go back to timesing by, it says 1.8 made it skinnier. But when I took this out and had 0.8, it was fatter. What about 0.2? It's again wider. So that's working. That's making it wider. Dividing by 5. Oh, that made it wider. Let's try fractions. We haven't tried any fractions. 3 over 4 made it wider. 5 over 4 made it skinnier because 5 over 4 is bigger than 1. So 1/4 made it wider. So anything, I'm again timesing, but now I'm timesing by a fraction. Basically, any number between 0 and 1 will make it wider. Or dividing by a number larger than 1 will make it wider. All right, next. Now we want to try to make it open down, which we haven't done yet. So adding and subtracting moved it up and down. Multiplying's made it fat and skinny. But in the hints it said negative numbers, which I haven't tried. So let's try negative number. Oh, well, look at that. -1. That's what that is. That works great. What about 2? Down, but skinny. I don't know if you can see that. It's down, but now it's skinnier. It's still down. Still down. Still down. So as long as it's negative, it'll open down. Okay. Let's try next. Move it down. Now we did this accidentally a minute ago. So when we were playing with trying to make it wider and skinnier and stuff, we accidentally moved it down, which if I recall was subtraction. That moves it down. That moves any number, so you can't really see, but move down. That moved it down. So basically subtracting any number seems to be moving it down. Okay, it wants my new vertex 5 units down, so there I am. That'll work. Next, try to move it up now. So subtracting moved it down. What about adding? Oh, that moves it up. Let's see, adding 1, adding 11. Oh, where'd it go? Oh, there it is. I moved up. 3. Okay. It wants me to move it up 5 units. There I am. 5 units up. No big deal. Next. Move right. Now, we haven't accidentally moved it right. We've moved it left, we moved it right. I saw some people in class try this. Adding a variable, which moves it both left and right. And I only want to move it right. So even though that works, I only want to go right, not left and right. I need to stay on the x-axis, my vertex. So what the other hint that's very confusing, in my opinion, is a hint, I couldn't figure out a good way to say this, is to use some parentheses. And I'm going to put x in parentheses, and I'm going to add or subtract first. So since I want to move to the right, I'm going to try adding. It wants me to move 3 units to the right, so I'm going to try to add 3, but it didn't. It moved left. That's bizarre. Why did it move left? No, it can't be. Yep, that moved left too. That moved left too. Huh. So it's hard to explain. But now it moved right. When I switched it to subtraction, it moved right. So it's very difficult to explain, but basically if I add a number to it, I'm going to be squaring a larger number, which moves it the other direction. So it moves it to the right. So subtraction will move it to the right inside. Any subtraction of any number goes right. Whoops, with the parentheses on it. Okay. Now we want to move left, and it says 7 units. So again, I'm going to have some parentheses. I'm going to square the parentheses and put an X inside my parentheses, making it larger and easier to read. I'm going to add, because that seemed to move left, 7. Very good and very straightforward. Like I said, easier to play with. It'll stick with you more than me just doing it for you. Now, I'm going to leave this one as a challenge. Now that we've played all these games, can you write me an equation, call it using patterns, so P of X for patterns, and then write me equations so that it does all these things. It's vertically stretched, opens down, move 5 units up, and moves 3 units to the left. So you're going to have equals parentheses X is going to get squared. We're going to have something in front, a number inside, and a number at the end. And then you're going to type down the vertex right here. Okay? So I'm leaving that one as a challenge for you. I'm not doing that one. Then we have our matching. And again, this is also a challenge. We've got these 3 ordered pairs. When I match something together, these do not go together. But see how now they're hooked together by the computer? So when you're matching, make sure you're hooking together. And you're trying to figure out which of these vertexes belong to these equations. And remember, the shifting left and right are the ones that belong, are the ones that are part of the vertex. And again, that's a challenge question. This is also a challenge question. What is the vertex of this bunch of letters? It's really still staring at you. It's really easy. Type down what happened. What did we do? Now, on this board behind me, you can sort of see that I have some notes about what happened. It's kind of hard to tell, but they're all there. Let's go like that. So anyway, I can't read them, but maybe you have better eyes than me. There's all the notes. And they're in reverse, so that's always fun. So good luck with that. But they're there. Okay. And then general equation. This is a challenge. So if you don't get to slide 12 and 13, that's okay, but the rest of it should be done. I hope you have a great day. See you guys soon.